Good afternoon. How are you guys doing? WebVR. Thank you. So my name is Andrew Moe. I'm the product manager for WebVR at Oculus. Thanks for joining us this afternoon. Michael and I are really excited to tell you about what we've been working on, bridging the world of web and VR. So for me, the story of WebVR is really a story of two groups of developers. The first group are the VR developers. They're the brave pioneers who ventured west before the frontier was mapped, and we really appreciate you for taking the leap into VR with us and for creating some amazing content for this brand new platform. But we recognize that you face a lot of challenges, and one of the biggest challenges is the size of audience that you can reach within VR. Let's say that you've created an amazing VR experience, like the upcoming Touch title, Dead and Buried. What is the best way for you to get this piece of content in front of the rest of the world? We think WebVR is one of the best ways to do that. Taking a cube map out of the game using the Oculus Unity utility, our developers have been able to add informational hotspots, text and images to create an interactive scene that you can explore on any modern browser. We've also added buttons that link you to various scenes within the game, which you can view on your mobile phone, panning the scene using your phone's gyroscope and using either gaze or tap to interact with the elements on screen. We know that it doesn't fully capture the immersive nature of VR, but we think that it's a pretty good way of convincing somebody to try VR. Despite the fact that there are millions of Gear VR and Rift users out there, we recognize that those with a VR headset still represent a very small group of die-hard early adopters, which pales in comparison to the over 3 billion web users that are out there today. And we believe WebVR's ability to reach this huge audience across multiple device platforms will make it one of the best drivers of VR adoption, giving the rest of the world a taste of what they're missing in VR. But in addition to allowing VR developers to reach a much larger audience outside of VR, WebVR also enables developers to create social interactions between VR and non-VR users. I'm not sure if this has happened to you, but there are many times when I'm in VR and I wish I could share the experience with one of my friends or family, but they don't have a VR headset. So let me show you a quick example of what that could be. It's an experience called OcuLoops. It was hacked together pretty quickly, so please don't have too high of a bar of the production quality. It literally was one developer a couple of weeks. But it goes to show you what you can do across device boundaries. And it's a music exploration experience for friends who are either on PC, mobile phone, or in VR. Let's check it out. Oh, hey, Casey. How's it going?
Hey, Andrew. How you doing over there?
What do you have built here?
Well, this is OcuLoops. It is a multiplayer music-making thing that uses WebVR.
Interesting. You want to show me how it works?
Yeah, let's do that. So you just look at a tile, and I'll just lay down a fat beat over here, like so. And then you can make some notes up here. Yeah. And then I'll just hit play.
Oh, neat. Can I give it a shot? All right. Let me pause here. Let's try to put some notes down. Are you able to see what I'm seeing?
Yep, sure can.
All right, let's give it a shot. All right, so that's not gonna, thank you, that's very generous of you. So clearly, this is not gonna replace Toybox anytime soon. But there are a couple of things I wanna highlight from that example that's pretty cool. One is, it's a persistent world that is synced between the PC client and me in VR. Next is, if you notice the somewhat creepy looking smiley face up there, that cube is actually representing your avatar, and it's tracked to the head position on your Rift, but also to where you're looking on PC. So you can gesture even outside of VR by moving your mouse up and down to do a head nod, left and right to do a shake, to kind of convey some simple emotions to your friends in VR. So that's a look at OcuLoops. So if the first group of the WebVR story was about the early pioneers, the VR developers, those who survived dysentery on the Oregon Trail, the next group is what I would like to call the web developers. This is a huge community that have yet to start building for VR. They're the big city folk who are a bit afraid to come out west, even though they have heard about all the gold that's buried out here. And let's be honest, the reason they're not building for VR is because it's very difficult to create content for VR. Those in this room know it better than anyone. And to create a performant, optimized experience in VR requires a special skill set that most web developers do not have. With WebVR, we're enabling developers to use existing, familiar web technologies to create simple, lightweight VR experiences. And to do that, we're building off of Facebook's React platform. React is one of the most popular libraries out there, used by some of the largest companies to power their websites and mobile apps. And we believe that by extending React and making the React VR library, we'll usher in an exponential growth of content and developers on the VR platform. And this is a great time, too, because we are seeing right now a proliferation of 360 media being captured and shared. And that trend will only continue as 360 cameras become more prevalent for consumers and professionals alike. So let's take a look at some of the web VR experiences that are being created by traditionally non-VR developers. First, we have an example of a 360 video by Ford in partnership with our Oculus London team. We're taking a 360 photo and giving you the ability to choose various scenes that you can jump to. So that's light interactivity that plays back on either a mobile phone, and there should be some sound to this. There we go. Or on a PC.
One of the things about Rallycross is that the race car we use is one of the quickest, most nimble race cars in the entire world. My new race car is an all-new for 2016 Ford Focus RS. It's a 4-cylinder turbocharged engine that puts out roughly 650 horsepower. It's an all-wheel drive system connected to a sequential
and in VR.
box. It can race on tarmac, on gravel, it can jump, and it can do 0 to 60 miles an hour in less than 2 seconds.
That's faster than a Formula 1 car.
So that experience is powered by the same piece of code, and there's no downloads or installation required for you to be able to access it. Second, we have an interior design tool built by the team at Visor. Imagine being able to start a project on your desktop PC in a browser to configure what a room would look like, and then sharing that with your roommate in VR to have them comment on whether or not you made the right choices. In this case, clearly, the white floors did not work out. And we see that some powerful potential is there for either working with architects, interior designers, or even furniture companies. Lastly, we have an experience titled Virtual SF by the team at FormVR, led by Tony Parisi, who's a pioneer of the VR in web and one of the co-inventors of VRML. So starting on a browser using open map data as well as the TripAdvisor API, you're able to transport yourself from various locations in the city and hover over buildings to take a look at what their hotel ratings and reviews are directly from the TripAdvisor backend. So we're literally taking 2D web information and transposing it into a virtual 3D space that you can explore. And obviously, because we're running this on our Rift, it also has positional tracking as well. So hopefully that gives you a good sense of what's possible being built with WebVR. And all of these examples and more are actually available on our Developer Center page, and we'll share that link at the end of this talk. So let me pause here a bit and tell you a little bit about the future. So we think that, as Nate mentioned, there will be two classes of experiences when you put on a headset in the future. There are native app experiences, and there are experiences powered by the open web. And for the open web to really succeed in VR, we think that there needs to be a first-class experience for enjoying this content. And that's why we're making the advancement to build a VR-optimized browser such that when you put on a headset, you're able to seamlessly discover, enjoy, and share all the web-powered VR experiences that we're creating. It will need to be tightly coupled with Oculus Home, need to be tuned for performance so that it runs at 60 or 90 frames per second, regardless of the experience. And it needs to be designed with navigation and input in VR in mind. The project is codenamed Carmel, and we will be showing a developer preview to those in this room and whoever is interested in creating content for WebVR later this year. But that's a vision of what's to come in the long term. Back to the here and now, I would like to introduce Michael Antonoff, co-founder and chief software architect at Oculus, to tell you a little bit about how to build for WebVR.
All right. Thank you, Andrew, and thank you all for coming. So Andrew has showed us a good number of kind of basic but also appealing experiences. Now I will talk a little bit more about the tech stack and what WebVR is, and also what Oculus is doing to make it all work. So first of all, here's a basic WebVR tech stack. Typically, you would have a browser in the bottom, which is supporting all the APIs. And there's been two common APIs which exist now, which is WebGL to make rendering in 3D work, and WebVR, which is a new standard which has been pioneered by Google and Mozilla and Microsoft, and we're working with it now to make this VR headset actually function. Now there is a number of other libraries which you can build on top of it in JavaScript. So Three.js is actually a popular library which does 3D rendering, making it very easy to display models and more advanced animation. And on top of that, we are putting the React VR and our UI libraries, which make it easy to interact with the world. Then you can choose, when you make your applications, how far down the stack you go. You can use React VR for simpler experiences, which also make use of our platform, or for some things you could choose all the way down to WebVR. So let me go over some of these technologies for those of you which may not be as familiar with them. So first of all, there's WebGL. WebGL these days is prevalent and working well in the browsers. So on the basics, it's similar to OpenGL. And one of the cool things about it is that it supports shaders, which means you can make attractive objects which look good. Now, on the basic of how it works is it allows you to create a WebGL from a canvas, which is an HTML object, and then you draw to it with draw calls. So you can do state changes for rendering. You could do rendering calls. Typically, you would call this function called the request animation frame, which would install a callback, which will call you every frame. That is where you do your rendering. Within that, you could do basic calls, such as GL viewport clear and draw arrays. Now, as for WebVR, this is a consortium effort which is shaping up right now in W3C. What it does, it enables you to access the headset, whether it's a Rift or any other device, through the JavaScript API. So you generally would have to do two things to use it. First, you'd do setup. So you would query for the headset display, returning your VR display object. And then once you're ready to do rendering, you would call request present. Now, once the VR is set up, you would do, again, per frame logic. You can install the frame callback, and then each frame you would get pose and other frame data. There's actually helper methods now to get you eye matrices which set up the view. Now, within the callback, you would do the rendering of each eye as required and submit frame. Submit frame on VR display is what actually gets it to show up on the headset. Now, these are kind of like low level, one could think almost C-like APIs. So if you take it higher notch, there's 3GS is one of the popular web VR libraries. So 3GS makes it much easier to make scenes in 3D. It is a scene graph model where you can add objects or containers of objects to each other within a tree. So you can make a mesh and put it in a scene fairly easily. So here in this little chunk of sample code, you're making the geometry and material with all the lighting description, and then you are creating a mesh and assigning it to the scene. That's all that's needed to display a cube, and of course, it's pretty easy to make things from that point on. Now, one interesting thing about web technologies and WebGL is one of the trickier parts is actually displaying text. This is actually the case for generally, I would say, computer graphics in 3D. Text is hard, and there's a number of different approaches people have taken for it. One is traditionally bitmap fonts. You just take your glyphs, you put them on a texture, and you display strings out of them. Alternatives for that are extruding geometry. So 3GS actually has an extension for that. And it allows you to make a geometrical shape and put it anywhere. At the same time, while it has volume, it's not quite as efficient if you want to display a lot of text. Another approach actually exists on the web is something called canvas text. So canvas is when you actually draw the scene into a 2D surface, including text, and you can bring it into the scene. Now, all of these work, but they have some aliasing issues. So one particular technology, which originally came from Valve a long time ago, was signed distance field fonts. So what these fonts are essentially specifically processed textures with shaders, which allow you to display characters with any scale in a world while still maintaining their sharp edges. So on the left here, you'd see kind of what an image could look like for a glyph if it was just a bitmap font scaled up. And on the right would be an image of what the glyph looks like with signed distance fields. So this is actually the technology we are putting into React VR and our UI libraries and bringing to you guys. And that is what the current demos are based on. So I would say right now there's a bit of a shortage of UI solutions within WebVR. So this is one area which we focused on. So let's talk a bit about React VR. In practice, we're actually making two separate libraries where there's a small helper library called OVR UI, which is essentially just a set of controls running in 3GS. It's kind of like a player. It allows you to easily set up a scene, put the objects there, and look around on all devices. It will work on your iPhone. If you'd look around, it will work on the Samsung phone. It will work also in VR. If you have a headset, it'll take you there. Now, the bigger part of a project is based on the Facebook's open source React VR platform. Now, if you are not familiar to React, there's actually several versions of it. There is the JavaScript version, which is essentially for the web. It makes a DOM tree which skins essentially a website. And then there is something called React Native. React Native allows you to target iOS and Android devices. And what it does essentially do calls to C++ or Objective-C, where it creates native components on that side. So in some ways, React VR is built similar to that, yet at the same time, it uses JavaScript, and it allows you to bring surfaces into the 3D world, which are laid out, as well as 3D objects and other content. So Before diving into all this 3D, I'll briefly give you a glance of what development in JavaScript with reactive native looks like. Here's an example of the most basic hello world you can do for an iPhone app, for example. Now, there's a few things to notice about this code. You're creating a component, in this case, called hello message, and you're adding it and registering it. Every application would usually have one component. Now, the interesting part is that it has something called a render function. And a render function returns essentially a tag, like a tag that looks kind of like HTML. So this is what's called JSX, and it describes a scene. Now, every time it's displayed, this function would be called to allow and support changes. Now, in the web, these days, something like this will be processed by another compiler to turn into the JavaScript, which actually can run in a browser. So in this case, this function and the text tag got converted into the create element call, which actually populates your scene. This is what the browser would actually execute, and it would correspond to ultimately a 3D graph within Three.js. So this is done by a tool called React Native Packager. And I won't go into too much details right now, but essentially it makes all the compilation automatic. So now that we talk about the 3D, let me briefly touch on the notion of coordinate systems. One of the things which layout does make it simpler is requiring it less specifying of coordinates, but you still need them for 3D. So for React, we've used the right-handed coordinate system and are recommending that people set up their world in meters to make it possible. Also, degrees have historically been used in React on the web, so we're sticking with that. Now, from now on, there'll be more code in the presentation, so it'll be raining code. I hope we can all stay dry. I'll kind of go into a few simple examples of what it takes to make a React scene. So a while ago, last year at Connect, John sat down and did a kind of a live coding demo of something called VR Script. And at the time, he took a few panorama images of his office in Dallas. Now I've pulled in the same images to kind of put together similar types of experiences. So here's the most trivial demo you can have. This is just headset with a panorama and a little bit of text. You could say this is like a React Hello world. You can look around, and here's the code that would be required to make it work. Similar to before, you have the body with a render function, which declares a few tags. You have a view, and essentially there are two components. Globe is the panorama view that you're seeing, the image which is loaded. And VR text has been placed at the 3D coordinate. In this case, I used -6 because the z-axis actually looks at you in the world. So to place an object which will be immediately visible, you would want to put them on the negative coordinates by default. A few other things you'll need to have include all the components you need with require statements, and the rest of it is pretty much boilerplate. So now that you know how to make this, let's do something a little bit more interesting. Let's say we want to add the most basic interactivity. In this case, I wanted to make a very little button. As you look around, it'll get highlighted. And then you can press on a Gear VR or on a gamepad and tap to update the counter. Here's the most basic other example. I've highlighted some of the code which is interesting here. First, in React, there's something called the notion of state. Every component that you make has a state of all the variables which are going to be rendered and could be modified to affect your scene. So in this case, we've declared two variables called gaze, which is a Boolean, whether its button is highlighted, and click count, which is the counter of how many times the message is displayed. Now, there is an onClick handler within the button object that you see. Button is a wrapper for text, which allows you to install logic handlers. So in this case, whenever onClick is called, the click count is set to click count +1. This would increment it. And in addition to that, you also see that the text component in the bottom, VR text, is actually displaying count plus the click count variable, which is what makes it happen. So whenever the state is updated, the scene code to render all of this is automatically called to generate the new scene. So now that we have ability to hook up logic to events, there's one more thing we might want to do. We want to make a VR to VR link. Let's say you want to go to a different site in VR. We can basically reuse the same logic, and in this case, we'll actually wrap it in a function to demonstrate that you can add handlers in your components. And we're using the React VR linking OpenURL API to head you to a different site. So in this case, it will take you and reload the page. There's one more thing I'd like to say about linking. Following links, while it's intuitive in applications, is a bit more challenging on the web. There's actually security implications around doing this. So in practice, when you cross a domain in a browser in the future, there's probably going to be some type of a UI, such as an interstitial or an image, which will let you know that you're actually at a new location, so you don't input your data and give it to somebody else. So these are the type of things we'll be working with the WebVR working group and the rest of the industry to make work well and securely. In the same time, we'll make sure that our player and everything we do does make it possible. So here's an example with a similar type of links. We are in Dallas again, and I followed the link to John Carmack's office. This is a video he took back then as well, the panorama. And I've been wondering what exactly he's coding on that screen, and I wasn't able to figure it out. So in this case, we've put a very basic list on top of it. It's several buttons, which kind of brings us to another notion, which is kind of popular both on the web and in React. And this is the notion of layout. Layout is basically arranging components, usually in 2D, which are automatically placed on a plane. Now, the most popular algorithm on the web is Flexbox algorithm for doing this. So React actually supports it natively, so you can apply it to a view. Typically, layout is based on either auto-computed values, so if you specify text, you'll know how big something is, or it's based on explicitly specified width and height. So in this case, when you place an orange button and yellow underneath it, it'll compute the height, and the next one will be put under it. Of course, in this case, we're placing it in space within a certain plane. There are other attributes you can assign to make this look better. So you can align it in rows or columns. You can specify alignment to left or right, such as flex start. And this will shift all the text around or spread it out depending on different components. So the justify and align attributes can be added to this. So here's an example of what that layout looks like in React. Here again, we have a view container, which says for layout, and we specify the column flex direction. We specify the 3D transform, which places it in a world. And then there is multiple frame items and text labels underneath it. So in this case, the frames are the borders. It has a color, and then a certain height and a margin. This is how layout would be computed and placed in space. And the text is, say, for example, 0.2 meters in height, and you can sort of see how it is. Now, of course, this is all very much 2D, and we've been talking a lot about 3D. So this is obviously an important part of WebVR, and it will be as we're going forward. So now for a moment, let's imagine that a mythical creature has invaded the Dallas office. So we decided to bring in and display it and rotate it on a scene. It's kind of the most basic other thing you might want to do. So here's the code which makes it possible. It's very similar to before. You have a view, and in this case, we've added a mesh with several transformations to it coming from a URL. We are loading an object file as possible, and we are, of course, adding a light to make it actually show up and not be black. So text is above. Now, one interesting thing is this transform statement. It actually includes several components. We've applied a different scale of 0.1. We're afraid that the creature was so big it would break down the walls. And we are concatenating several transformations together. This essentially allows you to more easily build up a scene with several transformations. These are executed right to left. Now, the other part is you see that we're using a variable, state rotation, right inside of that statement, which means that your object will get a dynamic value for it every time the render function is called. Here's what it takes to do the rotation. As we talked before about animation frame, in React, you also have something called request animation frame, which installs a handler called at whatever frame rate your headset is going to run it. So on Gear VR, this is going to be 60 frames a second, and Rift, it's going to be 90. So since the value is actually a variable, you want to adjust the rotation by the right amount of time which is passed. So in this case, we've used the date and time and the difference to update the state variable. This is what actually makes this rotation possible. So that's it for the little chunks of code for now. One of the questions you might be asking is, why React? I mean, there's other frameworks. There's A-Frame. There's a lot of other development. For me, there's actually a few things which make React compelling. So first, of course, it is a familiar existing framework. So there's lots of developers who have been both in Facebook and outside which have been using this technology. Now, the other thing, however, which is nice about it, is it combines declarative components together with the code which controls them. That makes it much easier to understand animation and interactivity in one central location. Another part which is really appealing is what we call an immediate mode rendering behavior. This is the idea that you could build up a scene almost as if it's built from scratch every time. And that actually makes your development significantly simpler. For those of us who worked in user interfaces, it may not sometimes be obvious. And me coming from a PC and component world, this was new. But it's actually a part of React which I really liked. So let us think about a state that you want to display. Let's say it's a bell with a notification. And it will say how many messages you haven't read yet. It could be a VR object. It could be a 2D object. Whatever it is, it can be in several different states. If we have, say, 8 messages, we would want to display a little object next to it which says how many messages you have. Now, of course, if you have no messages at all, you'd have a bell without any notifications. And let's suppose that we got completely spammed. Now we want to display 99 plus and put the objects on fire. So there's several different objects you're adding on top of each other. Now, how might you actually handle this logic? To do this, you have these separate states, and with somewhat naive code, you would be transitioning from any one of them to the other one. So let's say, for example, you are in the top state with 8 messages. A few things can happen. Let's say you open up another device and you've cleaned them out. So now you may want to go and remove the notification icon. Or let's say you got more. You may want to update the number from 8, let's just say, to 10. Or you can add a fire because now you've gotten so many messages. So what happens? How do you handle that? Well, typically in code, you'd have something like 3 branches. You'd say, if I'm in a state with a displayed number, and we are going down to 0, remove the icon. If we're going up to more than 100, add the fire, and otherwise just update itself. Now, if you actually think about the code that this takes, this is 3 conditional blocks. Now, and we only handled one state. If we wanted to handle all the possible interactions in UI, you would need at least 6 different transitions. And you can see how the number of interactions goes up quadratically with the number of states in your interface. So this is something which makes code really error-prone. So suddenly you're writing these long files handling all kinds of states. Now the good thing is that in React, since you're generating the whole scene from scratch, you are really going down the list, and you can just have 3 single blocks for the whole state transition. You just say, if there's more than one message, display the notification. Else, if there's more than 100, add a fire, and you're basically done. You've handled all of these with much more compact logic, and your code is much more maintainable. So that's actually one of the things I liked about React. Now, in terms of those of us who are game developers might be wondering, well, I'm calling a render function in JavaScript to process all of this every frame. How expensive is it if I'm going to building up all the objects and doing it? The answer is that it's actually an optimized system. So whenever a change is made, the changes actually propagate to the underlying 3D model, in this case, a 3GS tree. But the way it does it is that it actually avoids the processing of nodes which have not been updated. And also, it minimizes the number of changes. So even though you think you're recreating the whole scene, you are not necessarily doing that. So it's actually much more efficient than that. So one more thing I'd like to touch on is the notion of building. To me, this actually got me stumped when I first went to the web platform. In C++, we're all familiar with compiling things, and then you get an executable. But I expected you wouldn't have to do this for the web. And it's actually not quite the way things are right now. Today, you usually have tools such as Node, Package Manager, and others that you can pull in to download your code. And also preprocessors, which may convert JavaScript from JSX format, or let's say modern ECMA6, to the JavaScript which your browser can run. So the React toolchain actually takes care of a lot of this. There are 2 scenarios here. One, let's say, simple for development, and the second one is for distribution. So to actually develop on this, you typically would have to download Node.js, which is a popular library which started with for server development, but is now used for general scripting. And you do something like npm start. This starts a command line interface for React. It is essentially a background surface on your developer machine, which will automatically pick up all of your JavaScript and convert it to this format. So from that point on, you really don't have to do anything else. You can access a site. It will reference an internal bundle, which is built by that, and it would just work. So if you make changes in your code, it would be automatically updated and recompiled in background. Now, for distribution, you do something else. You do some commands such as npm build. This would actually pre-bake all your assets, take your JavaScript files, put them into one, and prepare it for packaging. So there's a bit more to that, but that's kind of a high level of something you would get used to. So now that we've talked about React, what about how we run it? We talked a bit about the Carmel preview, and I'm excited to actually, the fact that we'll be shipping this, an early preview of it next month. Now, what initial preview is going to be, it's an optimized version of it targeted specifically for Gear VR. So we have looked at things such as latency and performance, trying to make it the best possible experience for running the script. And its initial capabilities are going to be VR only. So there's not going to be a 2D browsing capability initially. It is essentially there to get you started developing in WebVR and getting ready for the more complete browser platform to follow. Now, what it will have, however, is touchpad support. You can do swipes and taps on your Gear VR, and it'll be exposed through buttons within a virtual gamepad. And it'll have Oculus Touch, similarly. and different input interfaces. It will also support VR to VR links. We talked about it a bit, and this is what makes it possible to go from one site to another. And in terms of using it, it should be pretty easy. You set up and host either local host for developer or on your site that you access, and you inject a link with an intent for, in case of Android, which will ship. Something like Ahref, Oculus, Web VR / whatever your site is. On Gear VR, this will automatically launch you into the player, take you to your site, and put you in the VR experience. Also, we'll be shipping a gallery of both sample experiences and different initial experiences you can access. In addition to Gear VR, this will also come on PC a bit later, and will kind of come along together with React as a separate package. So that's basically the summary of what we are doing. And I want to shout out and say thank you for Mike Armstrong right here in the front row, who actually did a lot of the coding on React. And